Welcome pre-cal students to class today on this Wednesday, March 5th. Hope you guys are doing well. Hope you're ready to learn some math today. There will be a test this Monday, so please keep that in mind. If you will not be attending that class period, I need to know no later than Sunday, so please let me know. And your integrity sheets are due by Monday. They're called integrity sheets because I trust you to be honest on those. Anything that you don't have done when you walk in the door Monday, you cannot do later. So please make sure you're all caught up on those, okay? Everyone has turned their quizzes in, so we're good there. Let's continue on. I hope you guys enjoyed your easy day yesterday because we are definitely going to make up for it over the next 2 days, okay? So make sure you understand that and make sure you're ready to work hard. The video will be pretty long today with a lot of information. However, there will not be any homework for you to work on today. Tomorrow, Thursday, there won't be any notes. You will have homework only. Now let me pause right here and say something to you two men. There will still be a video for you to watch tomorrow because I always want to communicate to you with announcements and reminders and stuff like that. So the video will probably be anywhere from 2 to 3 to 4 minutes long. So do look for that video, but there won't be any notes on that video, just announcements, stuff like that, and then you will have homework to work on Thursday, okay? If you have any questions on this, just contact me. Today we are going to be looking at how graphs move: left, right, up, down, flip vertically, flip sideways, stretch, shrink, all kinds of things, okay? So that's what we're going to do today. We're going to have a lot of pictures in your notes, a lot of things you're going to have to draw and write down, and a lot of side notes, okay? So even though when you started this video, whatever the video said, maybe it said 30 minutes, 45 minutes, the video is going to be longer than that because I really believe you're going to have to pause the video a lot and write some stuff down, okay? So please understand that. And my mouse, there goes, my pen was not working. Sorry about that. Okay, continue on. So movement of graphs, lesson 1.7 is your heading today, and the date is the 5th. Movement of graphs, lesson 1.7, and the date today is the 5th. All right, let's go ahead and get started. We need to get started by looking at some model graphs. So please turn in your books to the bottom of page 151 and the top of page 152. And if you don't want to turn there in your books, that's fine. But at least make note in your notes that the graphs on the bottom of page 151 and the top of 152 are very important, okay? You need to be very familiar with these. If not, basically memorize them. You need to know them, and they're really easy. Y equals x, let me get a red pen here, would be a straight line going through the origin and at 1, 1 and 0.22 and 0.33 and -1, -1 and -2, -2, and you draw a line, okay? This this squaring function, y equals x squared, maybe I could make some of these bigger. I'll just leave it like it is. It's a parabola. It goes to the origin, and then it goes through 1, 1, and then 2, 4, -1, +1, -2, +4. You don't need to memorize these ordered pairs at all. I'm just trying to show you basically what these graphs do. All right. Square root function. It starts here at the origin, and it goes like this. A cubing function. It comes up, slightly just kind of levels out a little bit, hits 0, 0, and then continues on. All of these should have arrows on them. A cubed root function. Notice a cubed root function kind of takes this function here and it flips it, and so it goes like this and kind of slightly narrows out there, and then it levels out, hits 0, 0, and then continues on. A 1 over x, a reciprocal function, okay? Here we have x to the 1, right? But if I took that x and moved it down to the bottom, I would have 1 over x to the 1 over x, and that's what we've done here. So they call it a reciprocal function, and notice it has a kind of a curve in the top right quadrant, quadrant number 1, and a curve in quadrant number 3, the bottom left quadrant, and it does not cross this imaginary dotted line, the y-axis, and it does not cross the x-axis either, okay? And then lastly, an absolute value function, y equals the absolute value of x. It's a v-shaped function that hits right here at 0, 0 and continues on like this. So be familiar with those. Let me grab a drink real quick. Be familiar with those because we are going to take those graphs that I just showed you here and we're going to be moving them all over the place. We're going to learn how to move them to the right, to the left, up, down, flip them, stretch them, shrink them, all kinds of things. So I'm not asking you to memorize these completely, but be very, very, very familiar with these graphs. Let's start off by taking a look at horizontal and vertical movements of graphs. In other words, horizontal, that means movements to the right and to the left, and vertical, movements up and down. Okay? Now, you're going to have to pause the video a lot and write graphs down. I'm not going to wait for you to do that, but you really need to do that, okay? All right, let's start off with the squaring function, y equals x squared. Here's the model graph right here in front of you, okay? Everybody see that? Now, Caleb, Matthew, take a look at this over here. Notice how we have x squared right here. And then over here, we've subtracted an x, or excuse me, we've subtracted a 6 or put a negative 6 directly to an x with the squared on the outside. Do you see that? So directly to the x, we have influenced the x with a number. Okay, a negative 6, and then the squares on the outside. Anytime a number is added or subtracted directly to the x, like this one is, that is going to be a horizontal movement. You will want to make a note of that. Somehow in your notes, circle this and draw a side note saying this is a horizontal movement. And by the way, it moves. I'm going to put horizontal movement. And it always moves the opposite of what you would think. In other words, you see a negative 6, so you think this graph would move 6 units to the left, and that's wrong. It moves 6 units to the right. If this was a positive 6, you would think it would move to the right, it would move to the left. So whenever it's a horizontal movement, it always is going to move the opposite way. Isn't that interesting? The opposite way. And when there's a number, now notice this, moving on. So whenever there's a number being added or subtracted directly to the x, like this, that's going to be a horizontal movement. Now, when there's a number being added or subtracted to the end of the function like this, not directly to the x, that is a vertical movement. And those do move. Did you catch that? Those do move the way you think they would. In other words, it's a positive 3, so the graph is going to shift up 3. If it was a negative 3, the graph would shift down 3 units. So what I want you to do in your notes is I want you to start off with this model graph here. Here it is. And now I want us to shift that graph alone and get the new graph, which is right here. So what we're doing is we're going to graph this function without doing any work. We're just going to pick up the model graph and move it. Let me change colors here, and here we go. Well, we know we have a negative 6 right here. That's going to be a movement to the right. So the origin, not the origin, the vertex right here is going to move over 1, 2, 3, 4, 5, 6. So there's the vertex right there. Then we see it's going to move up 3. So now I'm going to go up 3. 1, 2, 3. So I picked this whole graph up and I moved it to right here. And they say, Mr. Hart, what if my graph is not exactly like the other one? Guys, we're not into that. I'm not trying to, to teach art class here. I just want you to basically, you want to try to draw it as close to the other graph as possible because it really has not shrunk in or gotten wider, okay? But I'm not really that picky about it. Just make sure you shift it over and up like you're supposed to. And there, you did it. Isn't that easy? So horizontal and vertical shifts, are pretty easy as long as you remember which number moves it vertically and horizontally and which direction to go. Okay, let's try another one. Again, I'm going to move on the whole class period. You're going to have to pause it and write things down, okay? All right, here's a square root function. Okay, that was one of your model graphs that I put on the screen way back here, right here, okay? And so here's the model graph. Now look what we've done. Notice I have subtracted a 2 directly to the x. Notice how the x is under a radical, and I have subtracted 2 directly under the x, or directly under the radical right to the x. Now, if this equation right here had looked like this, just bear with me for a second. x's under the radical, the negative 2 right here. In fact, I shouldn't have scribbled this off. Do you see the difference between these two? Next, I erased my radical 2. Sorry about that. I'm making all kinds of mistakes today, aren't I? There we go. Do you see the difference between these two? Here, the negative 2 is being added or subtracted, whatever, directly to the x under the radical. Here, the negative 2 is just stuck at the end of the equation, not directly to the x. This would be a vertical shift, okay? And this problem here that we have is a horizontal shift because the 2 is being directly added or subtracted to the x. So we know that we're going to pick this graph up right here and we're going to move it right or left. It's a negative 2. You would think you would go to the left, but remember horizontal shifts are always the opposite. So we're going to pick up this graph and move it 2 units to the right. So we pick up this point here and we go over 1, 2, and there's the new graph. It just goes like this. Here we go. You did it. You shifted this graph 2 units to the right. No work to be shown, nothing like that. All right, let's take a look at this graph. Now, here is an absolute value function, okay? And notice I have put a negative 4 directly to the x and then a negative 3 on the outside. Well, if you've been watching and learning, hopefully you understand this negative 4 is going to be a horizontal shift, and this negative 3 is going to be a vertical shift. Okay, so the horizontal shift is a negative 4. We always go the opposite direction, so we're going to go positive 4. So let's pick up the vertex here and go over 1, 2, 3, 4. And then we have a vertical shift, excuse me, I hope I said that right. We have a horizontal shift of 4 to the right. You go the opposite of negative 4. And then we have a vertical shift of negative 3. So we go down 3. 1, 2, 3. So there we go. We pick up the graph. The vertex right here has now been moved to here. So you can go ahead and sketch your graph. You got a line going up like this, and then a line going up. And it's hard to draw on a mimeopad. You understand that? Like that. There we go. So that's basically it, students. Matthew and Caleb, when it comes to vertical and horizontal shifts, you're either having a number being added or subtracted directly to the x, or a number being added or subtracted to the end of the function, and that's what shifts the graph horizontally and vertically. Not too bad. Okay, now let's take a look at graphs being reflected across the x and the y-axis. Okay, now let's take a look at graphs being reflected across the x and y-axis. All right, let's go ahead and take a look here at what we have. Now I'm going to explain this the best that I can, but I want to warn you it's not easy to explain and it's not easy to understand. So please take some really good notes, listen well, and you might want to back the video up if you need to and watch it again. Okay, let's start over here. Now y equals 1/5 x to the 4th is this black graph right here. Not sure why I'm highlighting it in red, but it was a black graph. Okay, let me go ahead and erase that. So this black graph right here refers to this function here. Now, notice how the 1/5 became negative. Do you see that? So when we changed the sign, like this, when we changed this 1/5 to a negative, notice how it picked up the graph and it flipped it across the x-axis. We call that reflected across the x-axis. So if there's a point up here, it's like it swiveled and rotated. Okay, this point comes down here. This point here flips and comes down here. This point flips on the x-axis and comes down here. This point flips and comes here. Now, Mr. Earhart, that's easy to understand. Well, hold on, I'm not done. I want to show you something. Pretend for a second. Please take some notes on this and please listen, men. Watch this. Let's pretend the original function was this right here. Okay, just bear with me. Pretend this was not the original function. Pretend this was. It's not going to be flipped around the x-axis unless every single sign changes. So your 1/5 is going to be negative. Your 6 is going to be negative. and your 2 is going to be positive. In other words, are you listening to me, men? I was not very pleased with this example they gave in the book. I didn't feel like it was thorough enough, okay? Because a lot of students see this negative sign right here, and they're like, oh, okay, as long as you change the sign of the first number, then it flips around the x-axis. That's not true, okay? You have a reflection across the x-axis. They write it like this in the book. Are you ready? When they say you have, when f of x transfers over to negative f of x, and notice the negative is out front, that means it goes for the entire function, and that means every single term changes. Do you understand? So you have a reflection across the x-axis when every single term is changed. I hope that makes sense. You need to see that, because in a second, look over here. In a second, we're going to talk about how we're putting a negative sign directly to the x. Okay, and we'll get to that in a second. And that's when you have a reflection across the y-axis. So back over here, this is the easier one to understand out of these two. Let me get a drink here real quick. This one is a little easier to understand, okay? Because if every sign is changed, then you know that you have a reflection across the x-axis, okay? The x doesn't change, it's just the terms, the sign in front of each term. All right, now that is called a reflection across the x-axis. Take notes on this however you need to. Pause the video a lot, okay? Now, here's the original equation over here, and that's going to be the black graph right here, okay? Kind of a weird graph. Look at it. It comes up, and then it does a little kind of leveling out, then it shoots back up, then it hits this little hump here, and then it goes down again. Okay, now that's the graph of this function right here. Now, notice if everywhere there's an x, notice the 5 doesn't change. The 5 doesn't change. But everywhere there's an x, we have put a negative x directly inside the parentheses to the x with the power still on the outside. Do you see that? When that happens, when you put a negative x in directly for every single x that you have, the graph will then be reflected across the y-axis. So let me show you what I mean. See this black graph right here? I'm going to highlight it for you. Don't know why they don't have arrows on these, but they should. Okay, that black graph is being flipped across the y-axis. So see this point here? Let me change colors. See this point here? It's now over here. This graph was flipped over. See this point right here? Well, it was flipped across the y-axis to over here. See this point on the black graph right here? Well, it was flipped across the y-axis, so it landed right there. Okay? See this point on the black graph right here? See how far it was from the y-axis? It was that far over. Well, we go the same distance over. This point was flipped, and it's over here. And so then what happens is we get this red graph right here. It's the exact same graph as the black graph, only it's now totally flipped or reflected across the y-axis. So that's the difference. I hope you see that okay. Alright, let's go ahead and practice. Here we go. Alright, now I know these graphs are really, I guess we can call it kind of Bush League, not done very well, but it's the best I could come up with. So what I'd like you to do in your notes is go ahead and write these down the best you can. I would start with this problem here. Here is the original graph right here. Okay. And I guess to be honest with you, if I wanted to be really sharp, I should probably change these here to red and then graph them in red. So there we go. That's what I did. I quickly changed those over to red. Now, here's what we're going to do. We're going to take a look at this graph right here. Please watch carefully. Or not this graph, this function. We're going to look at this function, this black graph, and it's been graphed right down here for you, okay? Then we're going to look at the changes that have been made to it, and we're going to graph this function in red by just doing some shifting, okay? So here we go. Now, let's go ahead and get a color of red. if you'll notice, everywhere there was an X, I have put a negative X in. Do you see that? Everywhere there's an X, I put a negative X in. Well, what we just learned on the last page is every time you take an X like this right here and you substitute in a negative X, it reflects it across the y-axis. So we're going to reflect this across the y-axis. So if there's a point here, then there'll also be a point over here across the y-axis. If there's a point here, I'm just going to pick some random points, and there'll be a point right here. If there's a point here, that's over what, 3.5, then there'll be a point over here. And it'll still hit here, of course. And we'll continue working our way down. If there's a point here, then there would be a point about here on the graph, okay? And let's see here, can we continue this? This will be, I'm going to kind of try to sketch this kind of with a naked eye here. It looks like the black graph goes down and comes up. So with the red here, I'm going to come down. It won't be perfect, but I don't expect yours to be perfect either, okay? And it'll come down here. Then it'll curve back up. So this one came down and it curved back up. So this one will come down, it'll curve back up, it'll hit the origin just like the other one did. Now notice, look guys, watch the black graph. See my pen here? Follow the black graph. It goes down like this. So this one over here is going to come and it's going to curve down like that. And I guess you can put arrows on the end. So all that I did is I picked up the black graph and I simply flipped it or rotated it on the y-axis. That's it, guys. That's all that I did. Okay? So it's really not that difficult to do. Just look for kind of key points and move them across the y-axis. Now, moving on to this problem over here. Here is my black function. Here is my black graph. Now, here is my red function. Let's graph this red function in red down here. Now notice the change. Notice all that's happened is I changed the sign of this term from a positive 4 to a negative 4, and I changed, excuse me, this term right here to a positive. So when that happens, remember, when all of your signs change, the sign of each term, it's a reflection around or across the x-axis. So we have a reflection across the x-axis. I'm going to pick main points here. So I know this point is up here. So if it's way up here, that means I'll have a point way down here. See, I went across the x-axis. Over here, I went across the y-axis. Here, I'm going down across the x-axis. Okay? All right. So this point here will stay the same. Here's a point up here. So I'm going to put a point about right here. And then see this point way down here on the black graph? That means I'll have a point way up here on the red graph. So it's looking like me, just how just like the black graph comes down, curves up and goes down, then this one here is going to go like this. It's going to curve here, hit this, and then continue on its way up here. Now if you're struggling with this, you are not abnormal, you are normal. This is not super easy to see, okay? And maybe I can do one little trick here. I'm not sure if I can. Let me try something here. I wonder if I can take this. Just bear with me for a second while I try to have some fun here and play around with my tools here. Let's try something here. Yeah, I can flip it. Look at that. Okay, so it does it for me. So here's the original black graph. Remember, it was right there. Okay, so I'm going to grab that graph and bring it over here, and now I'm going to flip it. Let's get some space up here. There we go. I flipped it. And it's not going to be perfect, but notice how it should fall pretty much right on this graph here. So that's all that I did is I just took the black graph and I flipped it. Okay? And that's it. It rotated across the x-axis. All right, let's continue on. Now let's take finally, and I told you, however long the video is, it's going to be longer in real life. Sorry guys, excuse me. And the reason it's going to be longer in real life is you're going to have to pause the video a lot and write things down, okay? So finally, let's take a look at vertical and horizontal stretching and shrinking. And I don't want to scare you, but this is by far, in my opinion, the hardest concepts to understand, okay? So please watch carefully. All right, here we go. Please take some really good notes on this. Okay, let's start off with horizontal stretching and shrinking. Forget vertical. Right now we're dealing with horizontal. Now watch carefully what happens. Please listen. Please pause the video a lot and take a lot of notes. Don't try to rush through this. Remember, I've given you no homework today, and I've done that for a reason, so that you're really focused on these notes. Now watch what I do. Here's the original black function, and here's the black graph right here. Even though I highlighted it in red, there's the black graph of this function. Now notice what we did. We went directly to the x and we multiplied the x by 2. Notice how the power of 3 is on the outside. Notice how I went directly to the x, and on the inside I put a 2. Whenever you multiply the x directly by a number, it is going to influence the graph horizontally. It's either going to stretch it or shrink it, and we'll talk about that in just a second. Now, I want to show you something. Please listen to me as I show you something. If this graph, pretend for a second that this function would have had a +6 on the end, just pretend that it did, up here you would not have 2 times 6. You would not have that. You would just still have a 6. Okay, the only time you have horizontal stretching and shrinking is when you multiply directly to the x, in the parentheses, a number. It has to be multiplied to the x, because that's going to be different over here, and we're going to talk about that in a second. So the x's are what are directly influenced. Okay, now look at this. Notice on this graph right here, I multiplied each x directly by a 2. Notice on this function down here, I multiplied each x directly by a 1/2. So when that happens, when an x is directly multiplied by a number, it's going to either stretch or shrink the graph horizontally. Now look what happened. You would think when you'd multiply it by a 2, it would make it get wider, stretch it. It didn't. It shrunk it. Here's the black graph right here. That's the original graph. And then when I took the black graph and multiplied each x by 2, it shrunk it down. All right, so Mr. Earhart, what does that mean? Here's what it means. We're going to call the multiplier A. Anytime A is greater than 1, you want to write this down, guys, okay? Or less than -1, it's going to shrink the graph horizontally. Okay, so let me say it again. When you're dealing with horizontal stretching and shrinking, horizontal, forget vertical, we're going to get that in a second. Vertical is going to be the direct opposite of that. When you're dealing with horizontal stretching and shrinking, the multiplier, if it's less, did I do that wrong? Boy, guys, I'm sorry. Your old teacher here is just that. He's old, so I'm sorry. This should be greater than. If A is greater than 1 or less than -1, it's going to shrink it. But now look at this down here. Notice how you multiplied by 1/2, and look, here's the original black graph. See it? And it stretched it. It got wider. Okay, so what does that mean? Well, whenever your multiplier, this 1/2, we're going to call it A, whenever A is greater than -1 and less than 1, in other words, when it's between, when A is between -1 and 1, then you're going to get a stretch. It's going to become wider. Okay, so do understand that. Now I want to show you something else that's really, really, really cool that you need to see. I hope you're listening and taking some really good notes. Please watch this. This is so important that you see this, guys. You must get this. Notice how the points Let's use a point that we can all see. Okay, this point here, now watch this, is 1, 0. I told you guys this is the hardest part of the notes today. And notice how this point here is 1/2 0. Do you see that? So this point is 1, 0. This point right here is 1/2 0. Do you notice how the y value stayed the same? So when this point was shrunk and it was shrunk over to here, the y value stayed the same. So are you getting what I'm saying? When there is a horizontal what? Stretching or shrinking, the y values will stay the same. Now unless there was a vertical shift or a horizontal shift or a reflection, something like that. Other than that, if you just have this change from here to here, the y value stays the same. But notice what happened to the 1. It got divided by 2. Isn't that the opposite of what you did? Did you not? Now listen, did you not multiply each x by 2? Sure you did. But instead of each x value being multiplied by 2, it was divided by 2. Will it always be that way? Yes, always. Okay? So whatever you're doing here, instead of it being multiplied, it's going to do the opposite and divide. So because you multiplied each x by 2, each x value is going to be divided by 2. Down here is the opposite. Please look at this. Here's an ordered pair. That ordered pair is 1, 0. See this ordered pair right here? That ordered pair is 2, 0. So on the black graph, this point went from here over to here. It was stretched. And look how much. It was doubled. Was it not doubled? Notice how the y value stayed the same because we have a horizontal stretch. And notice how the x value went from 1 to 2. Now, you were multiplying by 1/2, were you not? But notice how the x value was really divided by 1/2. It was, yeah. If you take 1, see this one I'm circling. If you take 1 and type it into your calculator, type in 1 divided by 1/2, it'll give you 2. So it's kind of it's the opposite, okay? So here, when you multiply each x by 2, that means each x value is going to be divided by 2. Here you multiplied each x, excuse me, let me get a drink here. Here you multiplied each x value by 1/2. So the x values down here will be divided by 1/2 from the original point to the new point. That's how it's stretched. Now guys, if you got to pause the video and back it up and watch it again, I know that's like torture to listen to me teach twice as long, but do what you have to do to understand this and get this drilled into your heads. Okay, so how do we know we have a horizontal stretch or shift? When a number is multiplied directly to all of the x's in the function. Remember, if there would have been a plus 6 right here in the original function, up here you would have plus 6. You would not have anything being multiplied by it, okay? All right, now I'm going to create a little more room, so bear with me, all right, because we need some more space. All right, now we're going to talk about horizontal, or excuse me, now we're going to talk about vertical. Stretching and shrinking. All right, here we go. Now please listen carefully and I will explain this to you. Now, here's our original function right here. I'm not a fan of this example they gave in the book, but we're going to go with it, okay? And if you've been kind of going through your book and following, you can do that. All of this is in your book, going right in order. I have just taken pictures of their graphs and used them, okay? So that's up to you, how you take notes. You're big high school young men, Caleb, Matthew, you guys can figure this out. But here's the original function right here, okay? Now, notice what they've done. They have multiplied the entire function by 1/2. Here they've multiplied the entire function by 2. So let me put this in words you can understand. Let's say you had a function like this. You might want to write this down. Let's say you had, I don't know, 2x squared minus 3x. I just made that up, okay? And let's say you multiplied the entire function by 3. So now you have this. And then distribute your 3 through, and you would have 6x squared minus 9x. When you do something like that, when the entire function is multiplied by 1/2, or it's multiplied by 2, or some number, the entire function, this entire right side is multiplied by a number, that's when you have a, we're going to cross this off, we're done with this. That's when you have a vertical stretch or shrink. Do you see the difference? If not, pause the video and go back and look at your notes from the horizontal stretching and shrinking. Horizontal is when you multiply a number directly to the x, like this. Oh, it's very important you understand this, guys. Okay, my eraser's not quite working. If you were going to have a horizontal stretch or shift, then you would have multiplied directly to the x. I think it was a 3 that I used, wasn't it? Yes, it was. You would multiply directly to the x, a 3. Like that. Now, if directly to the x is multiplied a number, then that's going to be a horizontal stretch or shift. We did not do that, men. We did not do that. We multiplied the entire function by 3, and it went to each term, okay? Not directly to the x's. So when you have this here, that's when you have a vertical stretch or shrink. So with that in mind, now let's take a look at this. Here we go. Please watch carefully. All right. Let's go ahead and first of all get this out of the way so we're not confused. We'll come back to that in just a second. Now, take a look at these two graphs. Here's the original. And then notice I multiplied the entire function by 1/2, so that's what it looks like. So I have a vertical stretch or shrink, vertically up and down. Looks like it shrunk to me. See how high that point was there? And now let me get a different color of ink here. See how high that point was over here? And look how low it is over here. See how low this point was over here? It went up, it shrunk, it went up to here. Okay? Now the points on the x-axis just stay the same. But do you see what it's done? It shrunk. Now let me show you what that means. Are you ready? That means whenever your a is greater than -1 and less than -1, whenever a is between -1 and 1, then you're going to have a vertical shrink. Okay, now that's the opposite of horizontal. If you look in your notes, go ahead and take a look in your notes. You will see when it comes to horizontal stretching and shrinking, whenever a was greater than -1, less than 1, you had a stretch, a horizontal stretch, okay? And we don't have that here. It's the opposite when it comes to vertical. So, would you please make some notes on that? Take some notes and watch this. Look, notice how all of your x values stayed the same. -5, -5, -2, -2. 0 is your x value, 0. 2 is your x value, 2. 4 is your x value, 4. All of the x values stay the same when you're dealing with a vertical stretch or shrink. However, the y values change. And what happens to them? Well, what did you multiply the function by? 1/2. So what did each y value get multiplied by? 1/2. Okay, so here's your y value, 2. 2 times 1/2 is 1, so notice how the 2 became a 1. What about the 0? Well, fine. What's 0 times 1/2? Still 0. Look at this y value, -4. What's -4 times 1/2? -2. Now remember with see how this is so confusing, guys? I need you to watch this video maybe twice today. That's why I did not give you homework. You need to not just listen, you need to study this today and memorize stuff. I am not giving you, let me use a double negative, I am not giving you no homework because I want you to have an easy day. I'm doing that because I know how hard these notes are, and I know what kind of commitment it's going to take from you guys to learn this. Okay? Now remember with horizontal shifting it was the opposite. Remember when you multiplied by 2, look back in your notes, when you multiplied the entire function by 2, remember whatever it was, I forget what the function was, you were really multiplying the x values by not 2, you were really dividing by 2. Well, vertical is the complete opposite of all this, okay? pretty much these two situations, vertical and horizontal stretching and shrinking, are opposites of each other for the most part, if not completely. So because you multiplied f of x by what? Look right here, 1/2. That influenced all the y values by 1/2. So all the y values were multiplied by 1/2. Now let's go ahead and take a look at the situation with another graph. So let's say this is gone. Now take a look at this graph, okay? Now watch this. Okay, now notice, look what we did here. We have y equals f of x, and now look what we've done. We've taken f of x and we multiplied the entire function by 2. So that's going to be a vertical stretch or shrink. Well, it looks like it was a stretch to me. See how this point here went way up higher? See how this point here went way down lower? So we have a stretch, a vertical stretch. So when do you have a vertical stretch? Well, I'm glad you asked. When a is less than -1 or when a is greater than 1. And that's what I have. My a was a 2. I multiplied by a 2. By the way, this is the exact opposite of horizontal. Exact opposite, okay? All right, so look what happens here. Would you please look at each point? Watch this. Now, see this ordered pair right here? Notice how all of your x values stayed the same. -5 is -5, -2 is -2, 0 is 0, 2 is 2, 4 is 4. But your y values were multiplied by 2 because you multiplied the entire function by 2, so all of your y values were multiplied by 2. See how your y value is a 0? 0 times 2 is 0. See how your y value is 2? 2 times 2 is 4. See how your y value here is 0? 0 times 2 is 0. See how your y value is a -4? -4 times 2 is -8. See how your y value is 0? 0 times 2 is 0. That is called a vertical stretch. Man, guys, you know, I care about, I love all the students I teach, but you're going to have to learn this on your own, okay? I've explained it. You're going to have to rewind the video, listen to it, take extra side notes, and really, really, really make sure you're getting this, okay? All right, now, we're going to end the lesson today with one big problem. It's not going to take that long, so relax. It's not going to be long, but it's going to be a big problem, all right? So here we go. You can go ahead and take a second if you want and copy this in your notes so you have it. And we're going to take f of x, and notice we're going to multiply it by a 2, a -2. We're going to be subtracting 3 and adding 1. We're going to be doing a bunch of stuff to this graph, okay? So let's go ahead and take some notes on this. Go ahead and copy this in your notes, and then we're going to go ahead and work on this, and I'll walk you through it step by step. Now, this will not be a super easy problem, but if you'll take some notes and stick with me, I really think we can do this, okay? So, here we go. Make this a little bigger, and let's get started. Now, here's my original graph, y equals f of x. Here it is. Now you say, well, Mr. Hart, what's the actual equation? I don't know. They didn't give it to us. We're not going to worry about that. They're just simply calling this graph y equals f of x. Now, notice what we've done to f of x. Now please look at this, students. First of all, notice we have added or subtracted a number directly to the x. Okay? So you have parentheses, x minus 3. Then notice also we are adding a 1 outside, like to the end of the function. You need to get used to this notation, guys, okay? Then notice this. We're multiplying the entire f of x function by 2, but not only 2, a -2. So we're going to have a bunch of stretching, shifting, flipping, reflecting, horizontal, vertical movement, okay? Let me get a drink here. And let's get started. Now please listen to me carefully. Please learn to always do your stretching and your shifting first. Excuse me. Always learn to do your stretching and shrinking first. Please, students, if you don't do that, you're going to miss the problem. Always do your shrinking and stretching first. Can you do that? Okay, so here we go. Notice I'm taking the entire function and I'm multiplying it by 2. Now don't worry about the negative sign right now. That's going to influence how we flip it around the x or y axis. But notice how the entire function right here, this is not going to be easy, just bear with me and watch. Notice how the entire function is being multiplied by 2. Okay, let's go back a page. Remember in your notes, look at this. Perfect example, look at that. When the entire function is being multiplied by 2, like this, it's a vertical stretch or shrink. So now we know whether or not we're going to stretch it or shrink it vertically or horizontally. It's going to be vertical. Now look in your notes. Please look in your notes. The multiplier is 2. And if you'll look in your notes, I told you we have a stretch when a is less than -1 or when a is greater than 1. And we have 2, you can call it a -2, that's fine, which is less than -1. Or if you just want to look at it like it's a 2, and we'll talk about the negative sign later, that's fine. It's still 2 is greater than 1. Either way, you're going to have a stretch. And if you'll look in your notes, I told you what that means is you multiply each y value by the number. So in this case, we're multiplying by 2. So we're going to multiply each y value. I'm going to circle it in black. Multiply each y value by 2. Let's go ahead and do that. We're going to start off using black ink over here. So 0 times 2 is 0. So that ordered pair stays right there. 2 times 2 is 4. So I go -2, +4. We're multiplying every y value by 2. 0 times 2 is 0. So we stay right here. -4 times 2 is -8, so I'm still at 2, and I'm way down here at -8. And then 0 times 2 is 0, so we stay right here at 4. So there. So what I did, let me quickly sketch it, is I did a vertical stretch, and I multiplied every y value by 2. Now you're going to have to decide how you take notes on this, okay? So what I'm going to do is I'm going to try to get fancy here. So if you will allow me, please, to do this just for a second, trust me, and then do this. This is going to help me later be able to move that out of there, okay? Just trust me. Okay, very good. And now let's put this back up here where it was, okay? All right, there we go. Now, what I did is I took this graph and I multiplied all the y values by 2. So that took care of my stretching. Okay? Now, next, after you do your stretching first, your shrinking or stretching, let me say it again. Always do your stretching and shrinking first. Always, always, always. And we've done that. So now I really don't care what you do next. I'm going to do my vertical and horizontal movements. Those are pretty easy. I like those. So I'm going to go to red ink. See how I'm subtracting 3 directly to the x? Well, if you go way back in your notes, way back yonder, you'll see right here I taught you whenever you're subtracting or adding a number directly to the x, it's a horizontal movement, and you always move the opposite way. In this example, it was a -6, so we went 6 to the right. So with that in mind, because we have a -3, we're going to go 3 to the right. So I take this ordered pair right here, okay? I'll move it 3 to the right, 1, 2, 3. Move this ordered pair 3 to the right, 1, 2, 3. Take this ordered pair, move it 3 to the right, 1, 2, 3. Take this ordered pair, move it 3 to the right, 1, 2, 3. And take this ordered pair right here, move it 3 to the right. There. Now I'm going to go ahead, and the reason I earlier grouped all this together, I hope I can grab this black graph there, good, and get rid of it. So it's gone, and now I've moved everything to the right, 3 units. Okay? So I've taken care of my stretching. I've taken care of my horizontal movement. Now let's take care of vertical movements. See this +1 right here? That means I'm going to go up 1, +1. So I'm going to use green ink, and now each point goes up 1. So this one goes up 1, this point goes up 1, this point goes up 1, this point goes up 1, and this point goes up 1. Oh, I shouldn't have done that, and I apologize. I mean, I didn't make a mistake, but I want to be able to move this graph out of there later. Okay, do understand, it's very important. I can get rid of that so we're not confused. So let me quickly group that together. There we go. And now back to here. All right. So let's see, what did I do? Give your old teacher just a second here, all right? It was all to the right. let's see here. Okay, good. All right. And this would have been right here. If you're looking at your notes, there we go. It's right where it is, okay? All right. So now what I'm going to do is what I was saying is I'm going to take each one of these points and go up +1. So I'll put a point here. It's a vertical shift up 1. There's 5 points you have to move. Make sure you get them all. All right, there we go. Now let's get rid of this red graph. We've used it for all it's worth. We don't need it anymore. Let's get rid of it. And now let's go ahead and let's draw our graph. So there, then kind of sketch the curve, comes down, hits here, and curves back up. So let's review. Are you ready? Step 1, we stretched it vertically because there was a 2 being multiplied by the entire function. Number 2, excuse me. Number 2, we then did a vertical shift, +3, even though it's a -3, 3 to the right, and then we did a vertical shift 1. Now the only thing left to do is to see if we have any reflection across the x or y axis. Well, notice you have a negative sign here. Even though it was a 2, it was a -2. Well, let's go back in your notes and let's look at something, okay? Right here. Remember when I taught you, now please watch this, I taught you if you went directly to the x and made the x negative inside the parentheses, then it was going to be look at the arrows here, a reflection across the y-axis. But when you simply just go through and change all the signs, or in other words, you multiply the entire function by a negative sign, it's a reflection across the x-axis. Now, if it would have been like this, where you directly influence the x, let me show you what this problem would have looked like. We would have had this. We would have had 2f parentheses and then a negative x right here and then -3 plus 1. And if it would have looked like this, then that means we directly put a negative x in for the x. But notice it doesn't look like that. We have a negative on the outside, which means the entire function is getting a negative sign. So if you go back here to this example right here, when the entire function is getting a negative sign and all of these signs change over here, it's a reflection across the x-axis. This is the x-axis, a reflection across the x-axis. So what that means now is we're going to take all these points, and like if it's up here, we're going to move it across the x-axis to here. And by the way, once again, I apologize. Your old teacher's getting old here, but I need to group this together real quick so I can get rid of it later. Now, here's what we're doing. This point here flips across the y-axis to here. This point here is up how far? 1, 2, 3, 4, 5. So it gets flipped across the y-axis to 5 down here. This point is supposed to be right here, and so it's up 1, so it gets flipped to right here. This point is down here to wherever that was, so it gets flipped up here. And this point here gets flipped to right here. So now, having done that, I can grab this green graph, and that's not going to work. I can grab the green graph, and that's not going to work. And I can grab the green graph and pull it right here, and then go like this. Just like that. You don't have to do the sound effects if you don't want to. There we go. And there we go. Okay, so I hope this has been somewhat of a help to you. On how we're supposed to do this, okay? And so it's been flipped across the x-axis. I know this is not super easy, and I get that, guys. I understand that. But for the most part, what I need you to understand today is how to recognize vertical and horizontal shifts, reflections across the x and y axis, and vertical stretching and shrinking. And always do your stretching and shrinking first. Okay, watch this as many times as you need to. Make sure you're familiar with it. Tomorrow I'm going to give you homework. Alright, so tomorrow you'll have homework. Don't forget, there'll also be a quick video tomorrow, like 2 or 3 minutes, just making announcements and telling you stuff that's coming up in the future. Okay, have a good day. Call me or email me if you have any questions.